Now that we've learned a lot about parallelograms, our goal is to move in the opposite direction. So how can I prove that a quadrilateral is a parallelogram? And so many of these that we're going to see are going to actually just be the converses of our previous properties, but some of them will be a little bit different. So let's just go ahead and start with the first one, which is going to say that all I need to do to prove that a quadrilateral is a parallelogram is talk about the opposite sides being congruent. So here's a statement. It says that if a quadrilateral has two pairs of opposite sides congruent, then it is a parallelogram. All right, perfect. So, yeah, I'm going the other direction now. I'm trying to justify that something is a parallelogram. So I'm going to draw an object that looks like it could be a parallelogram, but of course I don't know that it is. And I'm just going to mark the things I know to be true, which is in this case that the opposite sides are congruent. So the question is, how am I actually going to prove this? And the answer is, well, as of right now, all I really have is my definition of what a parallelogram is, which is that the opposite sides are parallel. So to prove this, I will have to show that both pairs of opposite sides are parallel for my quadrilateral here. So I'm going to start with my opposite sides being congruent, which is that AD is congruent to BC, and that AB is congruent to DC. Now I'm trying to prove that ABCD is a parallelogram. Okay. So, how am I going to do this? And just like before, I'm going to talk about my congruent triangles. So, let me go ahead and add in this extra segment here, this diagonal from A to C. And I'm going to try and show that these two triangles are congruent to each other, and then somehow it's going to help me. We'll see how it is here in a second. But my first goal is just to prove these triangles are congruent. So this will actually be pretty straightforward. Won't be too bad. I actually only need one additional thing from what I'm already given to do this. But of course I just need to write it out. So number one, AD is congruent to BC. This is given to me. And then number two, AB is congruent to DC, also given to me. And then I just need one more part between these two triangles, and that is that AC is congruent to itself, congruent to AC. And this is, of course, the reflexive property. So now that I have this, I have my three pairs of sides are congruent, and so I can obviously just prove these triangles congruent by side, side, side. So triangle ABC is congruent to triangle, let's see, ABC to CDA by, oh, that's not what that says, CDA by side, side, side. So if the corresponding side, side, sides are congruent, then the triangles are congruent. So how does that help me? Because I proved these triangles congruent, that's okay, great. But how am I actually going to use that to talk about these lines being parallel? Because that's my end goal here. Well, so I have to think back to, a long time ago, how do I actually prove that lines are parallel to each other? And the way is I talk about their angles. So in this case, what my next goal is going to be is that since these triangles are congruent to each other, I can talk about, for example, BAC and ACD being congruent because they are corresponding angles between these two triangles. But then what they also are alternating interior angles between lines A, B, and CD with transversal AC. So that's going to be how I actually prove that these lines are parallel, is by using these alternate interior angles to do it. So let us go ahead and do that. So AB and CD are congruent to each other. Oh no, not that. Angle BAC, there we go. Angle BAC is congruent to angle, let's see, DCA. And this says, so two triangles are congruent if and only if their corresponding parts are congruent. Parts are congruent. Great. That comes from 4. And then I can say that, well, if these two angles are congruent, that means that AB and CD are parallel. AB and CD are parallel. And this is my alternate angle converse theorem that I can reference. So if the alternate interior angles are congruent, then the lines are parallel. Where does that come from? It comes from where my alternate angles were, which was number 5. And then I'm just going to do the exact same thing, but for this other pair of angles. So let me do that exact same thing again. Angle DAC, this is number 7. Then angle DAC is congruent to angle DAC to BCA. And this is going to be for the same reason as before. Two triangles are congruent if and only if their corresponding parts are congruent, which is going to lead me to talk about their the lines being parallel. This comes from, where did I say this? Back up in 4. And then finally, well, not finally, but statement number 8 will be that AD and BC will be parallel to each other. AD is parallel to BC. Number 8. If the alternate interior angles are congruent, then the lines are parallel. Comes from 7. Alright, so now that I've proven that both pairs of opposite sides are parallel, I can finally say the thing that I wanted to, which is that ABCD is a parallelogram. And the reason for that will just be my definition. Parallelogram. It's 9. If, no, not if, a quadrilateral is a parallelogram if and only if the opposite sides are parallel. And that's it. I'm going to reference 6 and 8. Okay, so let's just walk through this real quick one more time. What I was trying to show was that this quadrilateral is a parallelogram based off the fact that it has two pairs of opposite sides congruent. So what I did was, just like before, broke this up into two triangles, proved them as congruent, and then used their corresponding parts, which in this case were the angles, that allowed me to talk about these opposite sides being parallel. Once I had done that, it was just my definition at that point, which said that if both pairs of opposite sides are parallel, then it's a parallelogram. So this is one of the 5 ways that we'll end up learning how to prove that a quadrilateral is a parallelogram. Pretty straightforward, not too bad, but now we can use it moving forward.